Hello viewers, my name is Karina Harfouch, and today on this video I'm going to present to you my senior project and what I've accomplished during the semester. My senior project is the test case and automation management system, mentored by Tariq King, professor of FIU who also works for Ultimate Software, and my project team member is Justin Phillips. So, our problem definition would be the main theme of the problem is that Ultimate Software has many applications in order to manage and review test results for their software testing team, and this can result in time and money loss that's unnecessary if we could actually put all of these applications together and connect them to one application software that manages and synchronizes all of these test results and test suites and test cases. So here we listed four identified problems that are directly having to do with the contribution of my part of the project. So the first one is that one of the first problems is that updates and changes done in one application are not reflected or synced on the other application managing test suites and results. Direct automation of tests is unavailable from TFS or MTM. Test results are not directly available or easily acquired, since Ultimate Software manages and views their test results using a separate application which is called Phoenix. The test results are not summarized into meaningful data, which is one of my contributions as well to this project. Here's our Gantt chart. As you can see, this project was implemented during the fall semester, so my dates are from August up until December. Requirements of the station was done during August and September. We presented that deliverable in the middle of September, more specifically September 14. Then we start with the software project planning later in September. Software project organization was done between September and October. Then we started with system design, mainly on the month of October. For object design, like I said, in the month of October, and system implementation, since we're using an agile methodology, then the implementation was actually done throughout the whole semester, from September up until December, including testing. Development and testing. Present deliverable. The third one would be, or the second one would be on October, and then the final deliverable would have been in December, or in my case, May. Testing was done during the month of November, and that's pretty much, that sums it up, our schedule in our Gantt chart. These are the requirements. The ones that you see in bold were the ones that have been implemented, and the ones that are not in bold have not been implemented. There was not enough time. So I'm gonna describe to you the ones that we implemented. So we, for the application, we allow a single sign-on access, meaning that your Windows username should be able to be matched with the username on the database, and the application logs in using your Windows credentials without you having to do it manually. It provides an interface for creating, deleting, managing in general test suites, cases, and steps with fluid, intuitive authoring experience. Provide testers with the ability to add attachments and associate them with test suites and cases. It provides a mechanism to associate these tests with a code repository. Automation, actually the automation aspect of this requirement was implemented, but the code repository was not. So that part of this functionality is still to be implemented. There is no code repository that you can access as of now. Number 7, display test suites, cases, and steps in clean tree view. 8, provide a means to display data categorically and in a logical view. 9, provide a simple search interface for searching the test suite, cases, and steps. Provide a logout mechanism And the last two, which are tied to automation, and my contribution, which is to provide a set of metrics that allow the failure of cases, failure type, source code, and provide a visual of this data, results, and failure of metrics that you can easily see throughout a graph or through the user interface. This is the use case model. My area would be here using third-party test case management system, which is Phoenix, in order to be able to run automation and request data. Repository to link files, view change notifications, configure repositories. Here the user is able to log in and authenticate via the server, via RESTful services, and match that with a database. You can delete, create, synchronize all of your test case, and actually send that through in order for it to synchronize with TFS, which is Team Foundation Server, and MTM, which are the external applications that are going to interact along with Phoenix with our test case manager web application. Here's a sequence diagram of the attached file use case. It's pretty, so when you upload a file and you click, it is saved into the database, and then if you want to retrieve it, you can basically click there and be able to see what attachments have been saved and requested from the server through the database. Our system design is composed of our client, a controller model, server. So basically, when we're using the web application, we are requesting sending back and forth data to our different external systems, which is TFS, MTM, and Phoenix. So the system's overall architectural pattern is composed of a client server model where a backend system provides connectivity to data and operations on the data, while a client provides access of data to an end user. So in my case, on the Phoenix, using a Phoenix API, I am able to access my the Phoenix database through RESTful services, and it returns to me, once the automation is done, it returns to me a JSON string, which I can later decompose in order to show my data in a graph on the user interface. This is my system deployment, hardware and software required for the application. We have our Windows computer, which is the user end, where we are running the application. We have the application tier that ties the external software, which is TFS, Phoenix, web services, which I was talking about earlier, and our data tier, which we have our fixed static data, where we have saved all of our test suites and all the associated files and information along with that. And we have our build machine, build services, build process, and CAI object model, all interchanging data so that we can see it through our web application. This is the persistent data design. We can see here our TF case metrics. We have a metrics ID, test case ID, metrics fail cost, update date, in order to save data that has been retrieved from after automation has been run. The persistent data is managed via a database server and stored in a database. This data includes user permission information, external storage mapping, using IDs, and test plan data. For security and privacy, users, like I mentioned on the requirements slide, users are authenticated via Windows user identity. Anonymous authentication will not be allowed. In the course, which I will be talking about a little bit later on our demo, this one allows access to our Phoenix retrieve of information, so that interconnectivity is possible in order to access Phoenix test results via the API. This is a class diagram. As you can see, some of the classes have the delete, get, post, put methods in common, because these are the methods that are going to actually request, using the services, request the data from the other applications and request it through the from the server so that we can get that information back to our application. So we have the collections controller, home controller, logout, suite steps, the metrics, test plans controller, project controller, and test cases controller, which all have the delete, get, post, put, request methods. So back to my area, which is the metrics. This is what you would, the retrieve results you would see displayed something like this. This is how the database looks like from before that I was showing you. So basically, every time you run automation, the test results are saved, and then you will be able to get them displayed on a friendly, visually friendly way. So on this update type, we want to be able to have a trigger that every time that the automation is run, then we can actually save previous test cases so that we can later make predictions. So ideally, this every time test results are up, we should be able to save them on the database. So let me go quickly. I'll briefly show you how I tested the Phoenix API. So here we have Postman, which is the application that I used in order to test the Phoenix API in order to make sure that everything was correctly functioning once I run the API exe file. So as you can see, as I was talking about earlier, we have our get, delete, and post methods. So every time you run automation, you would first, on the back end, what's happening is that it's requesting with the post method, it's requesting from the server to actually run it. Depending on the file name, it's going to run a test, the test corresponding to that file. In this case, it's test1. So once that automation button is clicked, then it sends the request, and we should be able to run automation, and we see the results right there. Then we want to be able to tell the server that automation has been successfully completed. So that's where we use the delete method, and that delete method is going to tell us that automation has been successfully finished. So here we can see, make sure that when you're using the Postman application downloaded from the Chrome store, here these two should match. The file should match, because if not, then it's gonna get confused as to which test automation you're running. So once you do that, you get your results from your automation, and with a get method, you're gonna see on your application something like this. So here is the button I was talking about. So here you have delete success when you run automation, and then once you run it, you can access your results using the metrics button, right? And that is that little part of the demo. And our test run